Hi, welcome to Meshparts. This video shows the feature of finite element model of an aluminum profile in the Meshparts library. The component shown in the graphic is a structural aluminum profile from Bosch Rexroth. Meshparts has an online library of finite element models for manufacturer-specific components. These models are pre-processed and readily available for use in simulation. Once we select the profile or the corresponding macro, the model parameters should be shown in the right pane. The first parameter, which is named version, selects the profile variant. Double-clicking opens the database of available profiles. Here we see the available variants in the first column. The other columns list geometric properties, physical properties, and unit price. Selection can be done for single or multiple variants. The other parameters are listed below. We see the length parameter. This gives the end-to-end distance of the component. The unit and the data type is shown. The three angle parameters define the end conditions of the profile. The first two defines angular inclination of the cutting plane for the ends. The third angle parameter defines the angular deviation between the two cutting planes. The next parameter, named MS, is for mesh refinement. Smaller value makes the mesh finer. Values can be chosen from the list. Quad shape parameter is for the choice of elements. 0 is for linear and 1 is for quadratic interpolating elements. These quadratic elements have mid-side nodes and they give better accuracy in the computation. Fillet is the parameter that controls the minor details of the model. Sometimes the geometry of the model has little segments of curvature. Those leads to finer elements in the neighborhood. These curvatures often generates from the rounds and fillets of the geometry. We can vary this parameter and control what should be the smallest curvature allowed in the model. Here 0 means no fillets or rounds will be removed, and 1 means all fillets will be removed. In the additional information section, we find three buttons available. The geometry parameters button, which is the first button, shows the equivalence of CAD and finite element geometries. The model data sheet lists the model specific information, and manufacturer catalog button takes us to the manufacturer web page. All these models are interchangeable among different manufacturer products. That means a profile component in an assembly can be changed with another profile variant from another manufacturer. All these finite element models have similar predefined nodal components, so when one is replaced with another, all the connection, bonds, and positioning are maintained in the assembly. The definition of nodal sets can be found in the model tree. Two ends are defined as profile end A and profile end B. All sides are defined as side A, B, C, and D. The notches are defined in numbers. For the selected profile, there are 4 notches in the 4 sides. These are defined as notch 1, 2, 3, and 4. Each of these have 2 end nodes on both ends, 2 nodal sets, one on the outer surface and one in the inner surface. These nodal sets are useful for defining positioning and connection in a finite element assembly. The demonstration of a simple assembly is shown in another video. We want to see the deflection plot of the profile component. The lower end is fixed and the modal analysis is performed. We can see the deflection plot on the Meshparts viewing area. we have to select the CDB file in the Explorer and choose the Visualize Results from the context menu. In the assembly frame, there is a table called Results Sets. This table lists the sub-steps of the result. This is a modal analysis, so each of the sub-steps here is actually a mode shape. We can select the rows of the table to see the corresponding deflection plot. In the results quantity table, we can further refine the plot for the results in a specific direction of choice. The play button below is for animating the result, and the reset button restores the model to the pre-processing view. There is a deformation scale drop-down list to choose the scale of the plot. Besides this, Meshparts also have option to create an HTML report of the model. We can see the deformation plot and virtual reality results opening the HTML file.